Hi everyone, and this was the last slide that I showed you, indicating some of the books that I suggested that you considered giving to some of the people in your company relative to marketing analytics. And what we're going to do next is a recommender engine example that comes from the middle book, the marketing analytics book by Wayne Winston. So all of the examples in his book are done in Excel. So the question is, what are recommender engines? Uh, do they matter? Um, I'm going to talk a little bit about the Netflix competition if you've never heard of that, and then talk about the steps that are involved in creating a recommender engine, and then talk lastly about the major types. After we finish this section, I'll close this video off and then we'll go into the step-by-step approach to doing it in Excel. So what are some examples of recommender engines? So pretty much you've all seen recommender engines. You may not kind of have called them a recommender engine, but every kind of major IT company that's selling online has a recommender engine. In addition, even companies that are not online anymore are beginning to learn how to use recommender engines in order to generate increased sales, increased customer engagement. But here's some examples of recommender engines. So Amazon will show you customers who bought this item also bought this item. And as an example, I put down at the bottom, I like reading analytics books. So this is a picture that I captured, a screenshot down at the bottom down here of the books that I got recommended by Amazon. They're all related to um, statistics or analytics. Have you ever wondered how they created that list? Well, it's personalized for you, sort of, and we're going to see in detail how they actually do that. Netflix generates like 70% of the shows that get watched on Netflix are shows that were recommended by Netflix as one of their rows that are available to you when you log into the site. So if you've watched one movie, then they may offer you another movie that's similar. Spotify has recommended songs. Google has similar images. YouTube has recommended videos. Facebook recommends people that you might know. LinkedIn talks about jobs that you might be interested in. Over on the right-hand side of this slide, I have the jobs you might be interested in section right here that they offered me recently on LinkedIn. And then Coursera recommends kind of courses because you took a course in Excel before. They offer another course in Excel and they will offer you something similar. Waze offers you a best route. So if you wondered, like, hey, how do they do that? This is the class for you. So the other book that I had is a mandatory book and has a discussion about predicting individual recommendations for each customer. And it basically says that when you do make individual recommendations, rather than kind of generic, hey, here's the most popular things that are selling on the site today, if it's tailored toward you, then it's been shown that clearly that increases their sales. And it also increases your engagement. Engagement measured on a website is measured by click-through rates, um, and ultimately sales. Um, in addition, there's a study, since you guys are all coming through this rigorous DBA program, where that came out in 2019 that talks about how do you measure exactly how much value these recommender systems are adding. And there's a number of metrics over on the left-hand side that they suggest that are highly used out in industry. Click-through rates are you get to the front page and you click through to the next page based on something you saw on that first page. Adoption and conversion is when you get all the way through, somebody puts something in their basket and then actually completes a sale. Sales and revenue are kind of measured on a customer by customer basis under this point of view. And effects on sales distributions. The sales distribution is not probably what you think it is, so it really represents kind of other related items that get sold. So what's the range of the stuff in the basket that gets sold as opposed to just the item that they click through on. And then lastly, it's the user engagement and behavior. It's like all of your systems can track what people do when they're on your website. They know when you arrive, and then they track you as you do things, as you click on things on that individual website. So that's the user engagement and behavior. So here's a few observations from that research. Click-through rate up by 38% when you give the personalized recommendation on Google News. YouTube recommendations increase that click-through rate by 200% when compared with the most viewed video recommendation. Sales and revenue, 35% improvement on a DVD sales from an online retailer. Profit improved in an online bookstore by 28%. And this time they did what was called an A/B test. They actually removed the recommender for some people. And when they did, they saw revenue drop by 17% when they removed the recommendation from the website. So it kind of proves it in the other direction. And then lastly, user behavior improved in media streaming, which like Netflix or Spotify, which increased levels of user retention. Retention is super important because it's very expensive to get a new customer to join your business, but it's less expensive if you can retain them. So in that article that I presented a couple of slides earlier, they talk about different ways to measure the value of these in detail and whether or not it's easy or not to measure it. So some things like click-through rates are easy to measure because they can be captured easily by the system. Adoption is easy to measure as well. Sales and revenue, very informative. Sometimes you can't figure it out. Like overall sales went up when I incorporated the recommender engine, but how much of it was due to that or how much was due to some other aspect. And well, that phone call I just took was they've been trying to reach me related to my car's extended warranty. Obviously, they didn't use the recommender engine for that, so we're going to keep moving on. Sorry, I had to break there. So if you're interested in following through on reading some more about that or reading more about what we're going to talk about in the example on collaborative filtering, which is kind of the basis behind recommender algorithms, there's several different readings that you can have here. And then we're going to walk through in the next section a toy example spreadsheet that is adopted from that marketing analytics book that I showed you earlier. And I call it a toy example spreadsheet because it's super small and it's just illustrative purposes as opposed to what they would actually run at Amazon or Spotify. And we'll talk more about that as we go into the examples following this. So let's discuss how important this is in the real world. So Netflix a few years back ran a $1 million challenge. And today we would call that kind of a hackathon. They ran it on a website called Kaggle. And Kaggle is a website where companies can load their data up and put a challenge out there. People who are on Kaggle are data scientists and teams of data scientists, and they try to get the best outcome. And in some of these hackathons, they offer a prize. The prize might be you get points, so it's like gamification, and you get status, or it might be, in this case, it was $1 million prize that they offered. And they basically they gave the $1 million prize out to one team after they improve the measurement statistic that they use for determining whether or not their recommendation was effective to by 10%. So they achieved a 10% improvement over their Netflix previous methodology for making recommendations. So here's what that data set looked like from the Kaggle website. And you can still go pull these down if you're really interested in taking a deeper look at it. There were over 100 million, so this is a big data problem, ratings of 17,000, almost 18,000 movies by almost 500,000 customers. And so basically they laid out the rules for that. They even put in like a prize because they weren't sure how long it was going to take people to achieve the 10%. They put in a progress prize for each year that the contest was running before a team hit the 10% level. The progress prize was for $50,000. And, you know, all of this was available to anybody in the world who wanted to compete on it. And there is a great article that explains this competition here on this hyperlink. And I'm going to post it up here so you can see it. I'm going to get rid of this. At least I hope I'm going to get rid of this. And it has far more detail than what I just went through. So if you're interested in following up on that, I normally show these kind of things to people in my class so they can click on the hyperlinks that, you know, at their own leisure. So here's what happened. So I've mentioned before that there's a process that people use for evaluating the effectiveness of models. And we talked about that when we talked about the standard analytics process. So what happens is the company puts out 100 million movie ratings on the website, and they use that for what's called training. And training is the development of the initial model. Then you develop the model, develop the algorithm for predicting how people would score those individual movies, you know, 1 to 5. And based on that algorithm, it then gets tested on something that the company doesn't provide you. So you get this test data set, which is like 3 million ratings. So you build the model on the 100 million, you test it on the 3 million, and then the company then does an assessment of your answers compared to how people actually scored it. So if you said that it was a 4, but the person, your algorithm said it was a 4, but the person said it was a 5, then the difference would be involved in that root mean square error difference. And this root mean square error difference is what was used to determine the winner. It had to be 10% better than their current algorithm. But the last step that's in there is model deployment. It's like, yeah, you built this super cool model, but would the company actually use it? We'll talk about that a little bit more in a follow-on slide. One last thing I want to note about this whole process is that there was an academic article about, you know, all of this was those ratings were supposed to be anonymous on Netflix, but in fact, one academic organization showed that they could de-anonymize the Netflix rating by comparing them with IMDb ratings, which are public. So if you're interested in reading the article on that, you can actually check it out there. So Netflix never actually like implemented this algorithm. And there's an article here, if you click on the hyperlink, that talks about the fact that they didn't actually build out the final solution that they paid $1 million for because it was too algorithmically complex for them to implement. But what they did do, was it worth their while or not? Yes, it was worth their while. So what they did do was they took some key elements of the algorithm and implemented some of those key elements. So they didn't get the whole 10%, but it was definitely worth their while if you've been on Netflix. This thing happened in 2009. If you've been on there, you can see how much better they are today than they were back then. So the methodology that they use is a thing called collaborative filtering. So collaborative filtering is an approach to build an algorithm that predicts whether or not you're going to like something given the customer who you're predicting previous choices. So use that customer, and you also use other customers. And we're going to see that in a minute. Collaborative filtering is the process used by many recommendation engines. There are two main types. One is user-based. User-based means that you compare user 1 with a user 2 to make a recommendation to user 2. And then the second one is item-based. You compare item 1, like that book, that statistics book I just bought, with item 2, another statistics book that has a similar topic, and that allows you to make a recommendation based on the item. There is a third one I didn't list up here called the hybrid method. The hybrid is just a mix of the user-based and the item-based approaches. So here's a picture of what that looks like. So on the left-hand side, you see the user-based collaborative filtering. You take old customers and the recommendations you've made to them, and you compare customers that are very similar to that customer, and we'll talk about why they're similar. And as a result of their similarity, then you can make a recommendation 2, that's based on the similarities. That, you know, the old customer liked this, so the new customer will probably like it because they're very similar. Over on the right-hand side, what you see is the item-based approach, not the user-based approach. And basically, if you purchased similar items before, then you make recommendations that are very similar from the item-based review compared to based on what the other customer wanted. So you've got a list of all the items, and you've got the list of all the scores. And we're going to see this in just a minute, because what we're going to do is take restaurants, and we're going to say this restaurant is like that restaurant. And as a result, if I were going to make a recommendation on restaurants, you would say, oh, okay, I would pick a restaurant that's like that because they like that one, they might like this one. So that would be an example of an item-based collaborative filtering. So we're going to pause here. I'm going to save this, and next we're going to go into Excel, and we're actually going to build this recommendation engine ourselves. What you'll see here is, and we'll see it in just a minute, is that you can download the Excel file directly from a GitHub site. GitHub is a site that data scientists use to collaborate and exchange code, and also to exchange files. So we'll use that in just a minute. I'll see you on the next video.